Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled NFEEUC Model for Intelligent Clustering and CH Selection for Enhancing WSN Performance. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. I am Deepak. Today I am here to present you one of the recent research topic on which we were working and completed the things. So the application that we have designed is for sensor networks, especially for the wireless sensor networks and IoT based sensor networks, where we have used the neuro-fuzzy systems for the clustering purpose and many other tasks in that. So let's start with the video. Before starting the video, let's talk about that what we will cover into this video. In this video, we will initially talk about the application areas in which the developed protocol can be implemented in the real time. Then we will talk about whatever the code we have designed, how to execute it, what files it will have, and what are the software requirements for it. Along with that, we will discuss about that what is the state of art or other existing systems we're working on in the same domain, and what are the challenges found in that, and how our proposed methodology is handling it, and what technique we have implemented in it. Then finally, and experimental outcomes and the results will be given in the end to show the effectiveness of our proposed system. So let's start with the application areas. As the work is related to the sensor network, so it can be implemented in any of the areas like related to medical healthcare, where surveillance for the patients can be done from the remote locations. For the smart industries, where the human involvement is to be reduced by monitoring, controlling the systems through the sensors. For the agriculture domain, where it can be termed as smart farming. Other than that, for the defense related applications, so I have taken these application related images over here, so you can see the wearable devices that we currently using these days, like smart watch, logs, phones, and IoT devices. So all these are the example of the sensor network based applications. So the challenge in them is basically the sensors that we are using at the remote location or in the devices, they do work on the battery based systems. Those batteries are smaller in size, and because they are handy and can and is basically in the small devices, so it is very hard to keep the bigger battery powers with them. So that the challenge is like in order to maintain the battery consumption and let them stay for the longer period. So inspired from that, this energy efficient protocols has been proposed, and the research in this particular domain is being happening. So let's talk about the code that we have designed. So we will give you the folder in which the code is there. You can see this will be the code folder under which all the files of the developed system is there. The code is developed in the MATLAB itself, so you must have the MATLAB software with you. So the MATLAB version that I am using is R2019A, so you can use R2015, 16, 17, 8 or 19, but make sure the MATLAB version that you are using must be the full version, not the trial one, because in the trial one they are restricted with the libraries. Like, so now in order to run the code, you just need to go to the folder where the files are placed. So you just need to copy the path of the folder, then go to the MATLAB. You just need to paste the path here and press enter. When you will press enter, you can see in the current folder all the files available in the folder will be shown here. Now out of this, you just need to run the main files, that is scn1_2, scn3_4. so these are the main code files. Under this, we have called another few files like fuzzy1cr, cm, this, and nfs. So these are the other related files that I will talk later. And finally, a comparison code is being given. So main code files are into this. right? So in order to run the code, you just need to select the file whichever you want to run, and then you will click on the run button. When you will click on the run button, it will start executing. Here in the code we have developed it for the two scenarios. One of the scenarios like sync in the center and sync at the edge. So let's say I'm taking a 1 as a input. It means the first scenario will execute for scenario 1 underscore 2. When I will press OK, it will start processing the code. You can see the rounds are started. In the meantime the code is running, we will talk about the current problems and the current systems available and how what we have done. We have taken this base paper, which is a publication of uh, Journal of Ambient Intelligence and Humanized Computing. In this, they have developed the system of the fuzzy logic based scheme for the unequal multi-hopping clustering. In this particular method, what they have done, they have applied the fuzzy logics in order to do the four different tasks in the network. One is they were calculating the competition radius determination. Secondly, they are doing the cluster head election. Thirdly, cluster members are getting joined, and finally determining of the selection of the criteria for the next cluster head to communicate, right? So for this they have developed different fuzzy logics. Fuzzy logics are basically the controllers in which the input parameters have been given, and on the input parameter few rules are being defined, and on the rules base you can take the decision for any of the scenario. So what we have identified that fuzzy logic is a good approach, but when it is about any crucial decision or where the dynamic nature can be there, in order to hold that, fuzzy logic will be restricted because it will only focus on the rules that we have given. It is not that intelligent enough to take the decision in the scenarios in which they do not have the rules. So uh, we have we have identified the problem that in this particular scenarios, not for all the four stages fuzzy is best, but especially in the case of clustered selection, because that is a crucial part of transferring the data from one place to another, because choosing the best cluster head can determine the clusters, can determine how the data will transfer further, and even this CM joining and next hope selection is also dependent on the clustered selection. So in the proposed method we have replaced the fuzzy logic that is specifically used for the clustered selection with the neuro-fuzzy. So neuro-fuzzy is one of the domain under which the neural and the fuzzy logic systems are being combined. It means the fuzzy logic system is also designed for it, but for the rules few of the data set is given that combine the features of the neural network, which is capable to take the decision in the scenarios where rules are not there of the fuzzy. And fuzzy part is basically defining the input parameters and the output parameters within a specific range. So that particular domain is termed as neuro-fuzzy. So we have applied the neuro-fuzzy for the clustered election. Rest three of the scenarios are being done as similar as to of the base paper, because that they are holding a good outcomes from it. And finally did the comparison with the existing method. So let's see, as code is running, it will take some time to get executed because all the processing has been there, and finally we will see that what are the outcomes for it. So let's talk about the code. In this we have created the fuzzy files and one NFEEUC neuro-fuzzy file. So this is for the communication range determination, this is for cluster head selection, this is for joining the cluster members, and finally forming the relaying among the CH 1, 2 and 3. It is done by the normal fuzzy system which is already there in this paper. This one for the cluster head selection, the results we have achieved. For the cluster head selection, neuro-fuzzy based system has been developed. Now how this fuzzy are being designed, let me show you. These are the three files. This is for cluster ranging, this is for third fuzzy system, that is for cluster member chance, this is for cluster head relaying. These fuzzy systems have been developed. You just need to run this file. When you will run this file, it will save the FIS file, that is a fuzzy file, and you can further use this fuzzy file in the scenario here. So you can read it here, and by running these files you can save the conditional file, all the rules and the parameters those were used to decide the clustering range, cluster members and all these three functions has been used. Now for the neuro-fuzzy, whatever the proposed section is there, we have used this, in which the initial data set is created in the term of the rule, and then we have defined the fuzzy system for it, and finally we have trained the neuro-fuzzy network as per the data set and the fuzzy parameters that we decided, and finally on that we have final file has been saved in the FIS, which is quite similar to the normal fuzzy system, but it is a trained neural network with the fuzzy interference. So finally when we run this code, you can see initially we have loaded the files. Those are created by these four files. Then the network has been given, then the option is taken from the user that what will be the scenario you want to do. So in the base paper they have evaluated for different scenarios, one for the larger areas, another one for the smaller area. So we used for the small scale, in which one of the scenario they have used that with the 100 nodes and sync at the center, 100 nodes sync at the outside. In the second scenario, smaller scale, 1000 nodes sync at the center, 1000 nodes sync at the edge. Other than that, they have evaluated for the larger area also, but we have skipped that and implemented the smaller scale because most of the devices and all those things are being done into it. But it is expected if we are going for the larger scale where the area just they did is 500 by 500 instead of 100 by 100, so it is expected our proposed system will give the better results. So the results that we have achieved in this scenario, you can see this is the network that is designed for the scenario 2, in which the sink is in the sink is placed at the outside of 100 by 150, and then the scenario was first scenario, so you can see this is at the center 100 by 100, and the graph that we have achieved for this scenario is 100 cross 100 scenario 1. Here this EFUC, which was the traditional method, you can see the curve of the node is around 400 round and then get outdated and all the nodes get dead around 700 rounds. You can see the similar result in the base paper in the scenario of 100 comma 100. Here it is. So the curve for the alive node is around 700 rounds. The blue curve is of EEFUC. So we have take these results directly from the base paper and implemented here. The black curve is of our proposed method. So you can see our first node is dead, getting died at 900 round and get stable up to 1400 round, which shows our proposed system is providing better decision for the clustered selection by using the neuro-fuzzy and enhancing the lifetime. So similarly, the further factor we have compared is in the first node dead, half node dead, and last node dead. So here we have chosen two more methods from the base paper, EEUC and MOFCA, which is also in that base paper. You can see they have used these MOFCA and other methods. So we took the values from these tables. So from the table we have compared our proposed last node, first node, and half node deads. So you can see our curves are better than in comparison to the another two methods, so another three methods. So this proves our effectiveness. And in the other scenario, what we have done, we have just changed the nodes count. We set it to the 1000 because for the smaller areas they have done it for the small 100 nodes and the 1000 nodes with the two scenarios at a sink in the center and sink at the outside. So further modifications are still possible into this. For that you can contact us directly. For the real-time implementation in any IoT based devices where the communication can be a challenge and preserving their energy is under still research, so we can assist in that also. Thank you. Thanks for watching the video. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.